Any company engaged in finding the future is in a multi-billion-dollar race to get there. The most intangible element in that is not technology, manufacturing capability, it's design. Design.
Today we're seeing the creation of a brand new DNA for the automobile.
By the time of 2030, we'll have had a paradigm shift in the entire construction of the automobile.
I know that we are witnessing a convergence of revolutionary technologies.
Look down the highway, and you'll see the cars of the future. They are unlike anything you've driven before. They are unlike anything you've seen before. Chassis without engines. Cabins without steering wheels. Bodies stronger than steel and lighter than a bicycle. The future will challenge what you believe a car to be. This is Future Car. It's closer than you think. The future is coming from many directions. Cars that lean, cars that are virtual, cars that are ultra-light. Designers that push the envelope, and a chassis that will change the future. Technology will redefine automobiles, but what everyone really wants to know is, what will they look like?
The car hasn't really changed much in the past 80 years. It's basically a box on wheels.
The eye is not made for sharp corners.
It's about creating a passionate vehicular statement. That's the world of 2030 that I'm looking forward to. It's a full array of color, a full array of body styles, and vehicles that are capable of doing things that we haven't even conceived of yet.
Extreme designers who live in the future. Young designers who will be the future. And the bridge between them is Tom Peters.
What makes a Corvette are some very simple yet powerful elements of design.
Tom Peters connects a legendary past to what cars will be in the future. His design portfolio extends back to the 1986 Corvette Indy show car and forward to today's stunning Corvette Z06. He believes that if you understand classic design, you will understand future design.
When you look at this vehicle and compare it to where we are today, sure, they both have four wheels, but you can see the effect of where we've come since then.
From a designer's perspective, the difference is simple: shape.
This vehicle has to look high performance, but it also at the same time has to be beautiful.
Tom's classic designs do not defy convention. They are a bridge between the beautiful cars we can drive right now and the much wilder cars you will be driving in the future.
Hello, I'm Professor Luigi Colani. I am a three-dimensional philosopher of the future.
Luigi Colani has railed against conformity for decades. Why? Fluid efficiency. Mother Nature never used a straight edge.
Back in the 80s, designs were somewhat angular. And then I remember Luigi Colani coming onto the stage, very organic, very sculptural. And you could just see the passion.
We have to redesign, rethink all the parameters of the cars of tomorrow.
You will have very, very tiny urban vehicles. The smallest car with the biggest door, easy access, and then a very relaxed seating position, a wonderful, noiseless, small hydrogen engine, as big as a shoebox. It starts in my head as a thought, and then I discuss with myself on paper. I am knee-deep into car design because they are all wrong. The eye is not made for sharp corners. Soft shapes enhance us. They follow us all through life. And this car, all the lines are inspired by beautiful hips, bellies, breasts, and so on. All the best designs have something to do with those erotic shapes and the fluidity of forms.
But not all of Professor Kalani's inspirations come from the human form.
We call it a street ray. This is one of the byproducts of our biodesign thinking. We have this very soft shape, just covering the two front wheels with a very streamlined fuselage. People are saying Kalani is the inventor of biodesign, nature design. I'm not at all. It's nature that invented all the stuff. There's a big danger in being too far ahead of the game. This is the car for the throughways of tomorrow, so they don't understand your visions. And that's partially my problem. Crazy.
The future is not conventional in shapes, in materials, in purpose. If you want conventional transportation, take a bus. If you want the future, travel to Zurich.
Many people consider me to be crazy. Why crazy? Because we try to look in the future, creating our unusual concept cars.
Or in the case of the Zazen, the perfect blend of form and function.
We always start with a story. And the story of the Zazen means, in Japanese, meditation while sitting. It's a relaxation and getting rid of your environment. The Zazen has the biggest polycarbonate roof in the world. Polycarbonate is a plastic material which is basically unbreakable, unscratchable.
And many kilograms lighter than glass. A new material, creating a new design possibility.
The Zazen also has seats which are see-through, which make the interior very light. Also, the car has an adjustable suspension. The shock absorbers can not only be adjusted in height, going up and down, but also in stiffness, going from soft to hard, depending on the needs of the driver. The future everybody defines different. Today's new technologies allow a driver to say to the car, "Hello, here I am, I feel home."
Bonjour.
Great designers are unpredictable. Take Coqueline Courrèges, who fuses high fashion with high technology.
J'ai aucun diplôme. Je laisse mon instinct entre les rêves. Ce que j'essaye, c'est de les réaliser. Voilà qui je suis. En tant que couturier et en tant qu'artiste que nous sommes, la carrosserie n'est pas notre sujet, c'est une récréation. Seules les énergies m'intéressent. Donc, châssis tubulaire léger mais très solide, énergie, lithium, ion, polymère. Donc, la coupelle qui s'ouvre comme ça devant, j'ai enlevé les 4 portes, j'ai enlevé toutes les charnières, j'ai enlevé toute la structure. Et en plus, en inventant une bulle d'un seul morceau coqué à chaud, l'œil, il a 360 degrés. Je ne peux pas arriver à rentrer dans des murs où je ne vois pas. Pour moi, la visibilité d'une voiture, c'est un total 360 degrés. Pour celui qui conduit ou celui qui est assis, il doit pouvoir voir devant, sur les côtés, dessus. Pourquoi jaune? Jaune avec les pneus jaunes, jaune-blanc. Je retombe dans tous les coloris de l'explication des couleurs que nous avons dans la couture. Parce que le mouvement, c'est le mouvement. Un corps est toujours en mouvement. Rétroviseur, regarde derrière, moi je veux regarder devant. La visibilité pour moi, c'est regarder la vie.
I think the hardest thing about putting yourself as 2030 is We have no clue where the world is going to be.
And charting new territory beyond the future we expect are 7 bright young visionaries.
The General Motors Design College Intern Program is, I believe, the vision to the future.
My name is Ryan Patrick Joyce.
My name is Theandrew Claiborne.
My name is Zach Cranfield.
We look at hundreds of applicants and we narrow it down to just a handful.
My name is Mark Stropla.
안녕하세요. 저 이름은 박보연이고요.
My name's John Owens.
My name is Matt Zoller, and this is my testimony of the future. I like the idea of creating this sanctuary. I like the semantics in this sketch. Kind of say, hey, you can't really see out of this. This is a tech car. The windows purposefully are made to allow a little bit of light in, a little bit of interest. Like, what is that like driving down the road? Cars are going to be dictated by something that we don't even really know yet. Like right now, we're working on this project where we're trying to figure out what that really is. These arrows kind of show what would be a flexible LCD screen that would kind of wrap and come around you that would create this IMAX-type feel inside this car.
For a company to find the future, they've got to find the designers of the future.
What if the next car you buy will be the only car you ever have to buy again? What if you could have every model change, every upgrade, every new improvement added to the car you own in the blink of an eye? What if you could sit wherever you wanted when you drove? What if you didn't need a steering wheel, but could navigate using a joystick or a mouse? And what if you never burned a single drop of gas wherever you went? Because your car had no engine.
New technologies are coming together that will bring about a revolutionary change. One is significant as going from the horse-drawn carriage to the horseless carriage.
This is the skateboard. It is hydrogen fuel cells. It is drive-by-wire. And it will be many different cars and trucks.
Imagine being able to walk out of your home every morning and look at a 20-car garage, all of your favorite vehicles, and then shrinking that all into one vehicle, one architecture. That's what the skateboard can do.
The skateboard lends itself to body interchangeability. And because we don't have an engine at the front, we can have different size, different shaped bodies. And from an interior perspective, we can attach the seats in different locations and drive the vehicle from different seating positions. I am Chris Brony-Bird, and this is my testimony about the future. The real magic is in the thickness of this chassis. All of the hardware required to control and propel the 4 wheels are housed inside a 6-inch thick skateboard.
Suddenly, you're free to move the passengers and the contents of the vehicle. I have the freedom to make it look like the perfect iPod with wheels. By exposing these young interns to our skateboard concept, for them to look at the skateboard as an opportunity to do anything they wanted above that base, I think was a bit intimidating. When you give a designer a completely new perspective, a completely different premise for a vehicle, it will separate out a great designer from a good designer.
I really tried to utilize the fact that all of a sudden you have this space that you didn't have before. My name is Mark Stropla, and the GM Symmetry is my vision of the future. This interior sketch just shows the steering wheel could actually fold up to assist the driver in being able to get out from the front like this, and it would kind of fold down right in front of him into his lap. And so I did a symmetric from both planes, X and Y axis. There's a driver that faces forward, passenger that faces rearward, and then 2 passengers that face out the side, perpendicular. Right from the start, I knew that I really wanted to experiment with seating arrangements because you no longer have an engine right in front of you.
What it does have is a petroleum-free, zero-emissions power source sitting under the floor.
The fuel cell utilizes the energy from the hydrogen stored inside the skateboard to create electricity, which drives the wheel motors. Then, the spent hydrogen molecules unite with the oxygen in the air to create the only emission for the vehicle, water.
Fuel cell propulsion system has just 1/10 as many moving parts in it as today's automobile's internal combustion engine. And that's a dramatic opportunity for engineers to design vehicles and designers to style vehicles in the future.
If you want to change the steering feel, if you want to change the way the brakes feel, it will all be possible with drive-by-wire technology.
Drive-by-wire, similar in many ways to a video game controller. Every driving nuance expressed through electronic signals. Far more flexible and much faster responding than mechanical linkages. It's instant reaction, like flipping a switch.
My name's John Owens, and my vision for the future is the urban escape vehicle. Once you eliminate the mechanical linkages between steering and the wheels, or brakes and the wheels, or throttle and the engine, then it really opens up a lot of possibilities. My inspiration is both organic and mechanical, like the F-22 and crabs with the shell. Their articulation of their arms really inspired my suspension design.
In nearly every electric vehicle, there's a single electric motor that powers the front wheels. It's a propulsion story only. However, with the skateboard, we have 4 wheel motors, one at each corner, and it's much, much more than just propulsion.
4 wheel motors means superior traction and stability on all 4 points of road contact. Safe.
In addition, the driving dynamics as you go into a corner and as you experience the thrill of driving and the feedback that you get from that, it's going to be very precise.
Precision and stability. And for the young designer, the skateboard offers seemingly endless possibilities.
My name is Andrew Claiborne, and I designed the Firebird 5. The packaging became something very dominant, where the hydrogen would be placed, where the fuel stacks, the electricity to the motor. From those different aesthetics, I tried to create a vision of the future that would have that Hollywood showmanship.
Look at what these young people are doing. They're already exploring a variety of architectures. It shows just how mind-expanding the skateboard chassis is. And for any designer, you want to show the world your vision of the future. The skateboard's a way to do that.
Shape, weight, materials. The performance of our future cars will amaze us.
When you talk about performance cars and performance engineering, there's certain rules of physics you can't avoid. The largest enemy for dynamic performance is mass.
The Caparo T1, a lightning-fast accelerating and decelerating car. 0 to 100 to 0 in 8.5 seconds.
Our goal from the beginning was to try and achieve 1,000 brake horsepower per ton, which very few cars have actually achieved.
470 kilos, only 1,034 pounds.
Composites naturally can outperform most metallics like steel and aluminium. They're very good at energy absorption and they're very, very stiff.
Cornering at 3.5 Gs.
The car effectively doubles its weight at 150 miles an hour.
That means with a long enough stretch of tunnel, you could drive the Caparo upside down. How fast can a street-legal F1 car go? That fast. Total Rethink challenges current car design in every way, especially efficiency.
Why do you need 1.5 tons of steel to bring a human being of 80 kilos just from one place to another? Based on this very simple question, we asked, why do cars need that much fuel? Cars are getting bigger, less aerodynamic during the last decades. Loremo is a chassis concept. So this is where we focused on, creating a car having a minimum of weight and having a perfect aerodynamic. That's efficiency.
Loremo, low resistance mobility. The idea that low resistance is the ally of efficiency.
This car will have an outstanding mileage. It will make more than 150 miles on the gallon. The total weight of the car will be 450 kilos, which is about 1,000 pounds.
Low resistance, a formula based on weight and aerodynamics. But the enemy of low resistance has always been strength. But small does not have to mean weak.
The major invention we have with this car is this linear structure. If you hit a nail like this, it's very, very stiff because all the forces are running through the nail in a linear way.
Because there are no side doors, Loremo's uninterrupted longitudinal supports can be both stiff and lightweight.
we decided to start with a 2-cylinder turbocharged diesel engine. No matter what the source is, we need less energy. We need less electricity, we need less hydrogen, or we need less diesel. A Loremo always will be different, but it will be the most efficient car in the market.
The Loremo efficiency equation. Los Angeles to Denver, 1,000 miles, 7 gallons of gas.
I regard biomimetics as the abstraction of good design from nature. And we're seeing what we can take from biology and put into an engineering environment. We've been doing engineering, I suppose, for about 3,000 years now, from the Chinese onwards, but nature's been doing engineering for millions of years. And the advantage of this is that evolution and natural selection have sorted out all the bad designs and we're just left with the good ones. So a lot of the prototyping's been done already. Some people are doing research at the moment on what they call morphing structures, people in aerospace, for instance. And the idea here is that, like a bird's wing, you can change its shape according to the aerodynamic function. Now, is it possible, would it be worthwhile changing the shape of a car, for instance, so that when you have it in the city, it's a sort of short and upright thing, so that you can park it in a small space. But then when you go out into the country and you want the thing to be streamlined, it sort of squats down on the road and becomes a low, streamlined object.
Right now, car designers find themselves in the middle of the nano revolution, which will make tires and driving much, much safer.
Nanotechnology and the incorporation of carbon nanotubes will revolutionize the design of the automobile.
Nanotechnology is going to affect every component of the vehicle.
Using nanotechnology, scientists have developed the nanotube, an incredibly strong microcylinder made of carbon molecules.
This is a solution of functionalized carbon nanotubes. It only takes a few milligrams of nanomaterial to improve a rubber to where it's not breakable.
Right now, 50% of the weight of your tire is charcoal. It increases the stiffness of the rubber. But in increasing the stiffness, the rubber no longer stretches as much as we would like to conform to the road. We can add to it carbon nanotubes, affecting the ability of the rubber to stretch to 10 times its normal length. This would allow the tire to conform to the road much better, give much better adhesion, give much better wear resistance.
In the era of the total rethink, designers take everything one step further. So the answer to the age-old question, why reinvent the wheel, is simple. Because we can.
Tire. Wheel. Tweel. The strength of the pneumatic tire is its vertical compliance, but the weakness of the pneumatic tire is that it has a single point of failure. All it takes is a pinprick and you become non-functional. The Tweel provides the same functionality, but it does it without air.
It eliminates potential flats or blowouts on the road. The Tweel combines the tire and the wheel.
First, we have a tread similar to the modern radial tire. Underneath that, we have a specially reinforced tread band, and this structure is attached to a central metallic wheel via flexible polyurethane spokes that allows us to maintain flexibility as well as high strength.
The typical tire, when the tire is worn out, you throw away the entire structure. Or with the Tweel, you'll be able to replace the tread and recap it. That means less material put into the scrap pile.
We look at the ecological benefits, the added security.
You know what I think? I think the Tweels will be on the road in the not-too-distant future.
My name is Zach Cranfield, and the Autolux is my vision for 2030. If there's going to be autonomous driving, you don't have to sit in the front and face forward. You might as well create more of a home or like den or club-like environment where the people are opposed to each other and they can actually face each other and converse. I thought about incorporating actual wood onto the exterior. It's a luxury vehicle, but I want it to come across as flashy, just create a really elegant and sleek and clean design.
Cars versus cities. The battle is looming. Buildings cannot be moved. Streets cannot be widened. And with twice as many drivers on the road in 2030, designers are starting to create the perfect urban vehicle. Think fun. Think efficient. Think narrow.
Our cities are full of 5 and 7 and even more seat vehicles that are only carrying 1 and 2 people. If we imagine a bigger vehicle fleet, but of smaller vehicles, we can still do all the stuff we want. See, that's kind of wide for this street, that van. And if he's got stuff to carry in that van, that's fine, but the estate car that I drive round in, it's just as wide as that, and it really doesn't need to be. Imagine this street, same street, tranquil, quiet, but with two-way traffic on it, with narrow vehicles. There's a great deal of improved access that we can give in our cities if we accept the idea that vehicles don't have to be as wide as they currently are. This is the narrow. It is a free leaner. It's kind of like a motorcycle catamaran. It's like 2 motorcycles side by side. When we come round to the front, there's a linkage here that allows the car to move up and down on its suspension and give us some really good ride comfort over the lumps and bumps that we cross. But it also allows the vehicle to lean all the way this way. Now, when that happens, you can see the physics of the geometry, the forces and moments in the steering system. They've turned the wheels in. And when something leans over and turns in like this, it wants to make itself come back upright again. And that's exactly the same physics that a motorcycle uses to stabilize itself. Because this vehicle is very light, we have a very low power requirement. It means it can be among the first to adopt fuel cell technology, some revolutionary battery technology. Whatever the future of powertrains hold, this platform makes very light demands on it.
But to Damian Hardy, the Narrow is not only efficient, it's an elegant, sporty, 4-wheeled vehicle. And other designers are leaning in the same direction, on 3 wheels.
Our vision is that you need a 2-person vehicle for the future, 2 people sitting behind each other. That's how you can make a very fuel and energy efficient vehicle. And by tilting the vehicle like a motorbike, you can add an awful lot of fun.
The feeling you get inside when you're driving it, it's just like in an airplane. You have no lateral forces on your body. It's simply a great feeling.
Everything in nature tilts when it corners. With the Carver, you just take advantage of that. People even think that tilting vehicles make people go car sick, but it is in fact just the opposite. You get car sick in a car. You don't get that in a leaning, tilting vehicle like the Carver. You should steer the Carver just like a normal car, and there's a special hydraulic system which continuously adjusts the tilting angle. This is the hydraulic control valve connected to your steering wheel, and this is what makes the vehicle tilt. This hydraulic valve controls the oil flow to the tilting cylinders. There's one left and there's one right, and they push the passenger compartment from left to right. About 2 years ago, people from Viitorului Corporation in Japan came to us, and they were very attracted by our concept. They took the decision to turn one of our vehicles into a new styling interior and exterior. It had a completely new look to it, with the same technology inside.
The movement towards small vehicles is alive everywhere. From Europe to Asia to the studio of the design interns.
안녕하세요. 저 이름은 박보연이고요. 제가 생각하는 2030년 미래의 자동차는 이렇습니다. 2030년 때 그 제너레이션 I가 어떤 제 차는 2030년 때 제너레이션 I를 위한 자기가 좋아하는 일들을 하고 자기가
What if a car designer was to design a skyscraper? What if an architect was to design a car? What if a planner was designing the trains or changing the material of a train?
Some people imagine the future only as what is possible, but Dr. Mitchell Joachim and his fellow futurists at the MIT Media Lab are creating vehicles that seem closer to impossible.
Anymore, it's about
What would you call a theory that cars should be so soft that they run over a child and not hurt them?
Imagine if you're driving down the street and it's okay to make human contact or car-to-car contact.
You'd call it transology.
Rethinking the solution space.
The study of mobility and the environment.
The future is going to be a more profound synthesis between human mobility and the cities and the places that we dwell in. So why not think about cars that fit around cities? Gentle congestion is about rethinking the space of the street to be safer for children, safer for pedestrians, and safer for other motorists. Because the material of that car is made out of self-healing mats or pleated surfaces like clothing. You can patch it on the go, or something that's okay to scuff, like so many sheep moving together. The body doesn't have to be asked to absorb all the impact it would.
Transology is, in fact, an extreme vision that will inspire others to create. Your future is Mitchell Joachim's past.
Omnidirectional driving is a very strange kind of phenomenon that we're just beginning to comprehend. They're omnidirectional vehicles. They're moving in streams, in flocks, in herds that are controlled computationally. It's very similar to taking a helicopter and just driving it on the road, but it can move in any other direction. I think that the interns in their designs need to not so selfishly think about the car as an object or an artifact in the city, but need to think about the context, almost even more so than the actual object. So you're like facing each other like on a bus, and you're moving through the city, and this becomes, it's basically a moving viewing pavilion.
Just wait and see what your grandkids dream about. Cars that look like this. On a very rainy day in the future, a woman wants to take a drive in a beautiful sports car. But she wants to take a drive in the sunshine. If this were happening now, her Sunday drive would not be possible. But this is the story of virtual reality. Virtual reality will allow us to experience things that are not really happening, like sight, sound, touch, and yes, even driving. And virtual reality will bring less expensive, more efficient, and safer cars for all of us. The life cycle of a car model was once measured in generations because designing and building cars took that long. Sketching car designs and creating technical drawings took weeks and weeks.
That tool set that designers and manufacturing people have today is increasingly virtual.
Quarter scale, half scale, and full scale models made of clay and wood templates took months and months.
We used to do these full-size side view orthographic views. They take forever. They would take forever. And now you can do that within your own environment, in a math environment, see it instantly in 3 dimensions.
In the past, once a prototype was built, wind tunnel, aerodynamic, and live crash testing took many more months.
When you look at a virtual rendering and you put a physical clay model next to it, in 2030, you won't be able to tell the difference.
When we started to look at the concept, first of all, the canopy itself, how can we make something that is different? It's impossible to visualize it, how the effect would look like in the traditional process that we build models or clay models or hardware.
We sketch on computers where we sketch on the Cintiq screen, and then you can build in wireframes of curves, and then I can give those curves to somebody.
You can actually do a kind of simulation of how all the surfaces would interact with each other, and also if there would be interference when it opens. For example, is this door panel is going to hit the side of the car, the rocker panel of the car, and so on. The wraparound windshield, which has no interruption, is like a full canopy. The canopy is connected to part of the instrument panel. So the canopy opens up and also forward. And you cannot just start the engine until the whole canopy is closed. We have to look into the future, otherwise nobody would.
The thrill of the driving experience is not only about the wind in your hair, it's about the wind over your car. Aerodynamic testing affects how fast a car will go, how efficient it will be, and what it will look like. Aerodynamic testing also takes enormous space and a lot of money.
This is the largest wind tunnel in the world that's dedicated to automotive testing. We're currently sitting in the back leg of the tunnel. It's a closed loop that recirculates the air in front of our main fan here, which is a 43-foot diameter fan powered by a 4,500 horsepower motor. During our testing, we can generate speeds of up to 125 miles per hour, which is equivalent to a Category 3 hurricane.
But instead of creating hurricane force winds with each new design, now engineers have a better way.
Today, when we develop a new vehicle program, we use a combination of the experimental wind tunnel testing and virtual wind tunnel testing, or as we say, computational fluid dynamics analysis.
We're doing virtual testing with aeroflow, drag, ergonomics, starting off at the roof line all the way to the rear end tailgate.
The computational analysis allows us to delve more deeply into the details of what a particular surface will do, what effect a change to a particular corner might make.
They know the pressure points on the steel, and it calculates the drag resistance from that. They will be able to interactively move the surfaces in the 3D math model and see how that would affect drag resistance.
In the future, if I was to look into my crystal ball, I might see a designer who could create a virtual 3D sketch and using those same tools request an aerodynamic analysis and in a matter of moments have an estimate of the drag coefficient. The designers themselves will become the engineers.
Nothing is more real than a crash. Physical crash testing is expensive and time-consuming. But virtual crash testing means that more design and safety possibilities can be tested, which will greatly reduce trials, errors, and the loss of life.
The same idea is that you have a 3D math model built to the production specifications of meeting all the government requirements for safety, and then you literally crash them, and the software is smart enough to know how the metal would crumple, how the passenger compartment will be protected or not protected.
The play of the steering wheel, the feel of changing gears. Now designers have the virtual tools not only to see the car of the future, but to touch the car of the future.
And I can shift up through second gear, down third. Most people's experience of virtual reality is usually almost completely visual. Haptics means the use of compute power and software to generate tactile sensations, creating touch feedback where none would exist otherwise.
It's actually a touch and feel technology where you wear a glove.
And it's just a matter of software. It's just a matter of changing some variables to change exactly how much torque it takes to turn the wheel, how much feedback you get. It takes a lot of know-how about how the various nerves in the body interact and send information to the brain, how it's perceived, how responses are generated, and so on. It looks like this, and it feels like this. It looks like this, it feels like this. It looks like that as I push the cursor through that blue ball, and it feels like this. So with the Cyber Glove on, I think I'm gonna take a little ride. I'm gonna get in my car, and I can grab the virtual gear shift, and I can shift up through second gear, and I can feel the steering wheel. Not only feel it, I can turn it. You've got the ability to interact with a very elaborate model of an automobile interior and have increasingly authentic experience in interacting with all the different controls. So a car designer would love this, and they do love it, because it enables them to build any number of virtual models of how things might be laid out, where they might be, how they might interact with each other, and never make anything physical. It's all virtual.
The car is really about the interior, so that's where I began my exploration. Seating and driving in a new light. You're divided and put into separate areas, but it's still open. Autonomous driving is the future. You don't drive. You sit in the car and you're driven. The cocoon is the future.
For a young designer, the thought is always, what will it take to join the world's most exclusive club?
The odds of your son or daughter getting into the NBA are greater than they are making it into the automobile design field. It's an incredibly small community of a few hundred people around the world.
What will it take to be the next Kolani, the next Tom Peters, the next Coqueline Courage?
To find someone with the ability to envision a future product that evokes an emotional response. Finding those people is very, very difficult.
You've been drawing your whole life. You're going to art school. But that's a long way from designing a car that people will actually drive. However, one of car design's true masters has never produced a car that anyone has actually driven.
Sid Mead is a modern-time Leonardo.
I've been designing the future for my whole career, and I've been drawing the future since I was about 5 years old.
He's one of the most outstanding artists of this time. Absolutely stunning.
Sid Mead laid the groundwork for automotive visionaries, most notably in the film Blade Runner.
There was the spinner, which was a flying car. There was the taxi vehicle. The chance was to design a future world, and I had to imagine what junk parts you'd find in a junkyard in 2019.
Which set the stage for his vision of personal transport.
And in my mind, the future of personal transportation is a completely automated, take you where you want to go task, fulfilled by the machine, by the electronics, by roadways that are either wired or graphically marked so that the computer can follow and make a track.
Sid Mead, I think you would be hard-pressed to find a more influential designer in the world.
The trick is to bring the excitement of the first idea into the final result, which is actually possible to be built. That's the challenge of the modern-day designer.
And now, the interns are facing that very challenge. They have gone from the kernel of an idea to fully rendered model, each of them attempting to discern the future of cars. Some of them may well do it and go on to become members of the world's most exclusive club.
Good morning, everyone. Thank you all for coming. I'm Mark DRACULA from the University of Cincinnati. I kind of derived this package here, this symmetrical seating arrangement where there were 4 individuals, each facing different directions out the car. The doors would open up and allow each passenger to get in from all sides of the vehicle. And there would be flipped down, computer screens so they can have their digital communication and digital interaction that the Generation I is so used to.
This internship program is so important for the students and all of us at General Motors. It's a great learning experience for us all.
My name is Ryan Joyce from the Cleveland Institute of Art. I set out to design a cocoon, a truly transformative space that will take you from your very busy work life to your very busy home life and really calm you down and get ready for that change. We're delving into LCD windows, so when you are driving through Manhattan during rush hour, why not be in an island scene in Tahiti, or really transform your space?
I work with literally hundreds of the world's brightest designers, and I've been surprised. There have been some real surprises, believe me.
Hi, I'm Bo from CCS.
The young Korean, Bo Park, proves that inventive design transcends language. And so she envisions the nanny car, a driverless transporter of children.
It is for the kids aged between 8 and 14 who cannot drive.
So little Jessica will be able to drive herself to school. Picture a nanny that's 2 meters long, 1 meter wide, and weighs 600 pounds.
Each idea causes all of us to think, and maybe 1,000 other ideas come from each one of these very creative ideas.
You, the young designers of tomorrow, take the advantage of your youth. Put your paws on the oven, burn your hands.
There are those elements that seem to transcend time.
And as a designer, that's what we all strive for.